All right, y'all, we're gonna get started. So, just some announcements. Today is our last lecture. You won't have any lectures next week. In terms of the hack challenge, the midpoint, or not the midpoint is due on Monday. Or actually, I might honestly extend it for iOS to be due Tuesday, in case y'all have plans to leave for the break early. So I'm probably gonna extend that to Tuesday. But the roadmap form is due this Wednesday, or today actually. Yeah, roadmap form is due today, so make sure to fill that out. The link is actually in the other ed discussion, the Hack Challenge ed discussion. So make sure you fill that out. If you have a teammate that's like ghosting you or like not responding at all, then honestly you can just put y'all's name, like your other member's name, and then just leave them out. But email me so I can like keep track of those students. Okay, are there any questions? Yes. That's a great question. Let me try to remember. I don't think so. I'm not sure. I'll just do it just in case, but I don't remember if everyone has to do it or not. I think, honestly, yeah, just to be safe, everyone do it. But yeah. Okay. All right. Any other questions?
I believe you do have to fill. Everyone has to.
Everyone has to do it?
My semester, at least, I think we all have to do it.
Okay. Yeah, so everyone fill out your roadmap form tonight. All right. So today we're gonna go over SwiftUI part 2. So, okay. So last lecture we basically discussed SwiftUI. We talked about the difference between imperative versus declarative approach to making your apps, and then we discussed like what SwiftUI is, introduce how to create views with SwiftUI, why do we use structs for views, as well as kind of how to lay out your views. And then that was basically it for the previous lecture, more of like an introduction to SwiftUI. But now today, I'm going to take what you've learned in the previous lecture and actually make your apps a lot more useful. So in last lecture, we only created views for our apps. We never handled any kind of logic at all. And so most of our apps, obviously, there will have to be some kind of logic in a way. And so that's the point of today's demo, or today's lecture. But before I go into that, I first want to talk about navigation. And so in SwiftUI, you can use this thing called a navigation stack, which again, it's some struct, it's some view. Inside of that navigation stack, you want to put in the views in which you want to be able to push onto this navigation stack. So for example, if I want the text app dev to be a part of this stack, then I will want to put that view inside of that navigation stack. Now, you can think of this navigation stack as a UI navigation controller, right? It's still the same kind of idea of, pushing one view on top of another view. So that right there is the navigation stack. Now, this is actually, I can't move my camera, but this is actually only available in iOS 16. So the last time I gave this lecture, we used a navigation view, but now most of y'all probably have iOS 16. And so this time we want to use a navigation stack. Now, similarly to any other view we always have modifiers, which again are just methods that you attach to a view that creates a brand new view. Remember, it creates a brand new struct. So you can apply navigation modifiers to almost any view that you have inside. So you can have a navigation title, a navigation document, a bunch of other modifiers that you can add to this view. Now notice how I apply that modifier to the view inside of the navigation view, or this should be navigation stack, but I apply that to the view inside. So if I want to set a navigation title, I don't want to apply a modifier to the stack. I want to apply it to the view that's nested inside of the stack. Okay. Now, a navigation link is similar to kind of pushing and popping a UI view controller. So inside of this navigation stack, I have this navigation link. Now inside of that navigation link, the first thing I provide it is the view that you want to present, the view that you want to push. Whereas the label would be the view that you're tapping on. So most of the time, you can have a button in which you will put inside of this label right here. Now this label notation is known as a trailing closure. There's actually many different ways in which you can kind of write this navigation link, but this is the most common way and the way that I prefer to use it. So yeah, so the view that you're presenting at the top, the one at the bottom is the thing that you're pushing or the thing that you're tapping on. Okay, before I move on to a demo of navigation, are there any questions? All right, solid. Okay, so it will be a continuation of last lecture. I think there is more starter code to it. And so if you go inside the course textbook, there is a lecture 11 part. So go ahead and clone that, and y'all should be set. I'll give y'all like a couple of seconds to do that. By the way, you do need Xcode 15 in order to run it. Yes?
Sorry, just quickly on the roadmap form, at the top it says like only one response required per team. So I assume.
Okay. Take that back. I take that back. One response per team. Yeah. Yeah. Thanks for looking into that. All right. So we're gonna take a look at the content view. So remember, this content view is the entry point of this app. So if y'all look inside of this Bird Watch app, you can see that I have a content view inside of here. That right there is the entry point. So if I click on this, remember, this struct has one required property, and that is this body property. So every view that you want to present inside of this content view, you want to put it inside of this body property. Now remember, it has a return type of some view because we don't know exactly what kind of return type it is. Every time we add a modifier, it's changing the actual return type. So we don't know exactly what view it is. We know that it is some view. So now this right here is just basically a VStack containing a profile view as well as a button. So this right here on the right hand side, this is the profile view. This is the button. Now this profile view is just some VStack containing an image and then 3 texts. Now one thing that I forgot to mention last lecture is that you can actually kind of apply modifiers to a group of elements. So instead of, I could have just factored these text elements out and put it outside of this group, but that would mean that I would need to apply this modifier to every single element in here. But that's very tedious and I don't want to do that. So what I can do instead is group them and then apply this modifier to that group, and it will apply that to every single element inside. Now I can do the same thing to this VStack as well. So I could have put this inside of, attach it to the VStack, and it will apply to every text inside. Okay, and then the button is just basically a text. Yeah, it's just basically a text in which if I click on it, it should add, it should push a view in the navigation link that I mentioned before. Okay, so we first want to wrap all of our views inside of a navigation stack. So to do that, you just simply do navigation stack and then just wrap everything in here. All right, next up is we create a navigation link. So, navigation link. The first thing I want to provide it is the view that I want to push. Now the thing I want to push is this bird list view here. So this was the thing that we worked on last lecture. It's just basically a list of all of the birds. So what I'm going to do is call bird list view in here. Then we provide a trailing closure with the label, which is the button or the view that we want to click on. So that would be this button right here. Now notice how I could have used an actual button instead. So here I use a text, but there is one for a button, but it's actually a little bit different when you're dealing with a navigation link. This right here is sort of like a button. So instead of creating an actual button element, I will use a text instead. So now if I click on it, you can see that it just pushes and pops my view. Pretty simple. Now I want to add a title to this navigation or to this list right here. So to do that, remember, you don't want to apply it to this navigation stack. You want to apply it to the view inside. So I can put it here, navigation title, but I prefer doing it inside of the view itself. So right here, I'm gonna do .navigation title, and then I'm gonna call birds list. And I don't think the preview can show that unless Xcode got smarter, but we'll see. Okay, it kind of shows that. So you can see that the title right here is birds list. Okay, so that's basically it for navigation. It's very, very simple. A lot more, I guess, intuitive than in UI Kit. Okay, are there any questions about navigation? Yes.
So that it animated by default. Like, can you choose to have it animate?
Yeah. That I'm actually not quite sure. There might be a property that. This is a different animation, but there actually might be a way you can animate it, maybe inside of here. Yeah, I don't know, but there definitely is probably a way to do it. I'm actually not quite sure of the syntax though. What's up?
So if you wanted to make multiple pushes, right?
Yeah.
That work, would you have nested navigation links within this, or would it be you write a navigation link here, and then inside of the page that you push on, you write another navigation link?
Yeah, so this navigation stack right here, you only need one for the main outside view because everything is technically inside. But for every time we want to push a view, we would have to use a navigation link. So let's say inside of here, there's another button that pushes another view. In that case, inside of the bird list view, I would have that navigation link in there as well. Okay. All right, so now we're going to make our app a lot more interesting. I am going to create another button called add account. So every time I click on that, it's going to increment count by 1. So first, let's create that button. So it looks similar to this view birds button. So all I'm going to do is just copy and paste that code. And I'm going to call it add count button. Change the text to add count. Change the background to, I think I used green. And now I want to add this to this view. So inside of this view birds, what I'm going to do is put it inside of an H stack. So put this in here. And then before that, I'm going to add the add account button. So now you can see that the add account button gets added there. Okay. Now, I'm going to make this an actual button instead because it's actually not going to push a navigation link. So instead of a text, what I can do is just simply do button. Right here, I'm going to say do something, right? I'm going to do something here. And then I attach a trailing closure, which is the label that I want to add to this button. So it'll be this text label right here. Okay. So now you can see it's an actual button because if I'm clicking on this, it has that highlight. Okay, so what I'm going to do is increment count by 1. So over here, I have this text. I'm going to introduce some variable to the struct to hold that count. So I'm going to say, okay, why not just do a var count, make that an int, and let's start by initializing that to 0. And then what I'm going to do is use string interpolation and pass count in there. So now you can see that it says count 0. Now my goal is to increment count every time I click on this button. So the action that you want to do would go inside of here. So I'm going to say, okay, count plus equals 1. If you're not familiar with the syntax, it basically means count equals to count plus 1. So I'm adding 1 to count, and I'm assigning that equal to count. Or 1. All right. Now, it's giving me an error. So it's saying that self is immutable. It's saying that this count property is immutable. So does anyone have any idea why I can't do this? Think about how this view is being represented. What type is it?
the struct is a persistent data data type, so every time you increase the count, you have to rewrite it in memory.
Exactly. So we're using a struct, which is a value type. So every time we're changing its property, what's happening is that a new struct gets created. But we don't want that. So how can we modify the state of our app even though this thing is immutable? So that's like the tricky part of SwiftUI, and honestly, that's like the beauty of SwiftUI. So there's this thing called a property wrapper. A property wrapper is just some kind of annotation that you add to your properties that allow you to mutate it. And so what I can do is use this property wrapper called @states. Now this right here is the tricky part of SwiftUI. If you can really understand how and when to use these property wrappers, it will be really, really helpful when you create SwiftUI apps. So now after doing that, you can see that the error message goes away. So now if I click on add account, you can see that it increments count by 1. Now the nice thing about SwiftUI is that when you add these property wrappers, your view updates automatically. So every view that uses this count property gets updated every time it gets changed. So basically, SwiftUI is observing this count property. If it's changing, all views that use that will be updated automatically. No need to manually write code to do it. It'll do it for you. Now, because this view creates and it owns this property, we typically mark it as private because we don't really want anything else to access it. Now, it will work with private without it, but in this case, we want to use private just for good practice. So now, as you can see, it increments count by 1. Okay, are there any questions about @state? All right, so now, the second part of the demo, what I'm going to do is have 2 text fields, and then it's going to add a new bird into this list view right here. So that's my end goal. So then again, 2 text fields, get the value of the text fields, get the value of count, click add bird, click view birds, and it should be in there. So that's my goal. All right. So what I'm going to do first is let me just create this button. So it looks similar to add account. So I'm just going to copy this, paste it here, call it add bird button. This, remove that. And then in here, I would say add bird. And then I believe the color was orange. All right, so now I'm gonna add it to the stack. So underneath here, I can just say add bird button. Okay, so now when I click on it, my goal is to add a bird to this struct right here that I have. Okay. So first, I'm gonna change these 2 text labels into an actual text field. So what I'm going to do is say, okay, instead of a text, I'll introduce a text field. Text field. Now, it's missing a parameter for text. So this is the value, or this is the property that will store the text that you have in this text field. So for both of these, I'm going to create 2 properties. Right, so let me just do @state. So I can say @state private var location. It will be a string. Make that empty, and then @state private var. Make that the name. Make that empty. All right. So now I'm gonna introduce those variables inside of here. So name will be the name property. Text will be the location property. I think I made a typo. No, I didn't. Right. Okay, so now Xcode is giving me an error. It's kind of nice because it told me what to do, but you can't just really introduce this property here. You have to add this $sign symbol to it. Same thing for location. Now, what's the reason for that? Well, think about what this count text is doing. this count label that I had earlier, if I can find it. Honestly, I don't know where I put it. Oh, right here. So this text right here only reads the count property. Whereas in a text field, right, if I'm typing in here, so then, it's not just reading that property, but it's also writing to that property. In this case, we want to add a $sign, and what this does is that it creates a two-way binding with this property. In other words, it's a read and a write. So every time you have a view that's not just only reading that property, if it's also modifying that property in some way, you want to create a two-way binding by adding this $sign. So now, every time I change this value in here, what's happening is that this name property is getting changed as I go, right? That's the really nice thing about SwiftUI, the nice thing about using these property wrappers. It gets the state of the app changes with these views. So now what I'm going to do is that when I add bird, I'm going to add a new bird to this array. So let me just create a new bird object. The name will be the name property. Location will be the location. Image, there's a new image. I'm going to call it newbie. And then the count will be the count property.
Is this in the count bucket or the add bird?
Alright, you're right. This should be in the add bird. This is why copying and pasting is bad, because they look alike. But this should be in here. Okay. So now this is a new bird object, so let's say let bird equals to that. Now I'm just going to say birds, which is the array that I had earlier. I am just going to append this bird object to it. Now, one more thing I'm going to do, just to make our app look more clean, is these text fields and stuff, I'm just going to reset them back to empty strings. So every time I add a bird, I want to reset everything. So let count equals 0 again. So now let's try to do this. Name, I will put, who should I put? I'll put Caitlin. And then location, she's from California. So now let me increment count by 5. Hit add bird. You can see that these text fields get deleted. And now if I hit view birds, scroll down, you can see that, well, I don't know why Caitlin's not showing. I think it might be an issue with the preview, but Caitlin should be showing right here. Yeah, I don't know why it's not showing, but it should show right there. Wait, actually, I know why. It's because this thing happened before. So let me try it again. There you go. So yeah, it's because I set this into equal to an empty string, and then I added after. So that's why it was empty. Okay. Are there any other questions? No? Okay, sounds good. All right. So now, just to recap what property wrappers are. So remember, we use @state if the view itself creates and it owns the instance you want to wrap. So earlier, I had this property right here. Because this content view owns it and it created it, by creating, I mean that it initialized a value to it. Then you want to use @state. And then remember, the type that you want to wrap with this @state property wrapper must be a value type. So if it's a struct, if it's a integer, if it's a string, those are value types. Then you want to use the @states. And we typically mark them as private for best practice because nothing should really modifying the property that we own. And then you want to do a read and a write. You create a two-way binding by using this $sign. So I only mentioned about value types, right? I only introduced an int, a string, and structs. Now what about reference types? So what I'm going to do is I am going to use another demo. There isn't a code for this, but y'all can just follow along. So what I have here is I introduce a struct, which is some user. Now this user has a first name and a last name, and then I use this @state property wrapper for this user, and then I just have a text with a name, and then text fields that does a two-way binding for the user's first name and last name. So now if I change this right here, you can see that it updates live for me. So this two-way binding is writing to this first name property of the struct, and then it's also this thing is also reading the new changes to it. So everything is happening live. SwiftUI updates the views automatically for you. Now this works. Why? Because this is a struct. This is a value type. I can use @state on it. But most of the time when we have some user, usually we kind of reference that in a class. That's because it's being passed to multiple views, and so this view isn't the only view that's owning it, right? We might pass it to other views. In that case, we want to use a reference type. We want to keep that same user, that same reference. So instead of a struct, all right, let me use a class. So number preview is going to finish loading. So now, if I try to change it, you can see that it doesn't update anymore. Now, why is it doing that? Well, as I mentioned before, @state only works for value types. But how does @state really work, and why does it only use for value types? That's because it observed the entire object itself. Whenever we had a struct, those properties, I was changing it right here. So what's happening is that it's creating a brand new struct. @state observes the entire thing. And because that entire struct gets created, or gets a new struct gets created when I change its properties, it knows that, hey, watch this entire struct. If that entire struct gets deleted and a new one gets created, then update views. That's why it worked. But when we use a reference type, when we use a class, the object itself, the instance itself, does not change. It stays there. Only these properties are being changed. So the same reference to that object still remains. That's why @state doesn't work. So the solution to this is there's another property wrapper that you want to use called @state object. Now we want to use this for a value type. Now it's still giving me an error because it's saying that my object right here must conform to this protocol called observable object. So now if I try to change it, you can see that it still doesn't work. That's because there's one more property wrapper that you want to add to your properties. It's called @published. And this should be a capital P. So now, what this does is that it's observing this reference type. If this property were to change, then update views. So now if I change the first name, you can see that that gets changed. Whereas the last name doesn't have @published, so now if I change it, it doesn't change at all. Okay. Are there any questions about reference types? All right, sounds good. So then again, @state object is similar to @states, but it's used whenever you're using a reference type. So you're using it on some kind of observable object. And so in the example earlier, I used it on this class, which is an observable object. So that class, that object that I create will be observed, and the properties that I mark with @publish, those properties will be observed whenever I change them. And so you want to use it if the view itself creates and it owns it. So in the example earlier, I created an actual user object. That's why I can use @state object. But now, right, I introduce value types. What about reference types? Now, what if the view doesn't actually own the property, right? Most of the time, you can get your data from another view. Just like in one of the assignments, right? You're getting your view from another view controller. What if you have multiple screens? Then you need to pass that data to another view. So how can you change the data from one screen from another. In UIKit, in the imperative approach, we used delegation, for example. That child view controller uses a delegate to update the text or update something in the parent view controller. But SwiftUI is reactive in nature, right? It observes these data and then it'll update your views automatically for you. So to do that for views that do not own that property, you want to use this property wrapper called @binding. So @state creates it and @binding receives that property. So it's similar to just @state, but instead of actually initializing a value, you actually retrieve that from something else. So you still use a $sign for a two-way binding, and you still want to use it for a value type. But the only difference is that it's from some parent view. So I'm not going to demo, but let's say this right here. I created this count in here, right? I created that property. Now, inside of the list view, for example, if I wanted to use it, I can just say, well, var, let's say count is an int. I don't initialize it to any value because I'm going to pass it in somewhere. So if that value is immutable, then I can just simply pass in, let's say borderless view, I can say count is equal to count. So if that property was immutable, then I can do it here, right? I can just do it like this. But let's say something inside of this class or something inside of the struct modify that property. In that case, I want to use @binding here because it's getting that same property from parents. If you were to modify it here, what it's going to do is that it's automatically going to update the views right here. And then you would have to use a $sign here because the child view is modifying and it's reading that property. Okay, does @binding make sense? Are there any questions? All right. So, in addition to @binding, obviously we have value types, reference types. We have value types if you own it, reference types if you own it. This is a value type if you don't own it. We also have a reference type if you don't own it. That's @observed object. So @state object creates it and @observed object receives it. So that user example that I had earlier, right? This user, if I were to pass this in to another class, so I create it here, but let's say some other view in here needed to use that, it also needed to modify that. I would just, inside of that view, instead of using @state object, I would do @observed object and not initialize it any value because it's getting that from some parents. And then again, you still want to use it on some observable object in which its @published properties are being notified if you change it. Alright, so now it gets even more complicated. Now, that right there was just only a relationship between one view and another view, so from a parent to a child. But now what if you want to share it to almost every single view? You don't want to keep passing that to every single view. You want it to be stored in some environment. Which is why there's also another property wrapper called @environment object. So it's similar to @observed object, except you can share it to multiple views. So remember @observed object, the view itself doesn't create or own it, it's getting it from some parents. But instead of using @observed from getting from one parent, well, I guess they're both still used from one parent, but you have to pass in that one source. Whereas from @environment object, you get it as soon as the app launches. So right here, let's say this app right here, if inside of here, so this is where my app gets launched, I can introduce, let's say in here, I can introduce an environment object. So let's say I create some object here. If I pass in the object here, what it's going to do is that every view will have access to that environment object. I don't need to pass it in. By just simply calling it, like somewhere right here, it will have access to it. Now this is very, very common when you're dealing with networking, right? Remember how we had like a network manager class in which you had all the backend calls? Well, similarly, we can do that with some network manager object. If I want to access that, if I want to do something with that, I can use it with the environment object property wrapper. So I can simply just access it from any view that I want. Now, so I know that was a lot. There are a lot of property wrappers available for you to use. So just to quickly recap, if you own it, if it's immutable, right, you don't want to change that value, or that value, nothing really reads from it and nothing is changing it, then you want to create a regular property, right? Just do var. But if it's a value that you want to observe or other views are kind of using, then you want to use @states. But remember, you can only do it if you're owning it. If it's an observable object, if it's a reference type, then you want to use @state object. Now, if it's from some parent, again, immutable value, you can just use a regular property. But if it's mutable in some way, then you want to use @binding. If it's a reference type and you want it to be mutable, then use @observed object. Last but not least, if it's from some environment, then there's actually this property called @environment. So these are actually built in to Swift. So there's like a lot of really cool environment properties that you can have. For example, if you want to dismiss a view controller with a button, then you can just introduce an environment property that will dismiss it for you. So there's some really, really cool environment properties that you can create. But if it's some kind of observable object that you want to get from the environment, then you want to use @environment object. Okay. But then sometimes the data actually comes from the disk, right? Remember, we had persistence, we had user defaults. So if it comes from a disk, for example, user defaults, if it's stored inside of an entire app, we want to use @app storage. So remember how we had user defaults. If you're reading it from some view, or you're reading it from user defaults, you could just do that with the @app storage property wrapper and just simply attach that to some property. What it's going to do is that it's going to match the name and then read it from user defaults. And then obviously if you modify that property, it's going to change user defaults. Now this single scene and core data stuff is a little bit advanced, but you can use core data or even like Swift data to do persistence. And for single scenes, this scene only matters if you're doing like Mac OS apps. And so yeah, the cool thing about SwiftUI is that it's actually cross-platform. So you can actually build Mac OS apps, iPad OS apps in SwiftUI, even the new Vision OS. Okay, so the last time I gave this lecture, iOS 17 was not introduced yet. But now iOS 17 is introduced. So basically, almost everything that I told y'all earlier, almost everything, you can kind of just forget about it. That's because iOS 17 actually made your life a lot easier. So remember, the class that we had, we conform it to a protocol called observable object. We're basically saying that you can observe it. But now, Swift decided to say, okay, so a bunch of our developers might be dumb, so we're going to make it easier for them. We're just going to add, well, you have to import that library, but then you're just going to add the @observable property wrapper to your class. Now, remember how we had @state object, @observable object, @environment object? We don't need that anymore. We could just simply use @state, and it'll handle value types, it'll handle reference types, it'll handle a lot of things. So if you have a reference type, you can just simply use @observable, and then you don't need to worry about state object, none of that. You can just simply use @state and then @binding. So it works for value types and reference types. And it works for, whether or not you own it. So that's actually a really cool thing. But the reason why I taught y'all the other things is because most of the time you will probably develop apps that aren't in iOS 17 yet, because this is like brand new. But yeah, that's something cool that Apple introduced. Okay. Yes.
So when you say like developing apps in iOS 17, like if we were to develop it using this, like would it not like work in iOS 16?
Exactly. Yeah. So like even like a lot of apps on app dev, we like Ithaca Transit for example. I was actually trying to fix a bug for it, and I ran the code base, and it was very old, and the reason for a lot of the bugs was because a lot of things we used was deprecated, right? It was written back in like 2016, 2017. A lot of that stuff is deprecated, and so it causes a lot of issues. And so, you know, I decided to bump it up. I might rewrite it or something, but they're gonna make it, or I'm gonna make it available for like iOS 16 or 17 because that's, you know, what most people are using nowadays. And obviously, I want to use it for these new features. Okay, are there any questions about SwiftUI, anything in general? All right. So yeah, you should definitely create apps in SwiftUI. It's honestly a lot faster, and as y'all can see, it's a lot more intuitive creating views. The only different part is you think of it in more of a declarative way rather than an imperative way, right? But it's nice to have these property wrappers that honestly just like it modifies the views for you. It automatically updates the views. Yeah, you can definitely use this on a hack challenge if you like, but other than that, that's basically it. That's the end of our lecture, our last lecture. It'll be my last lecture too. I'm not teaching next semester. Actually, I might come by for like a guest lecture on SwiftUI again. But yeah, before I like wrap up, I just want to say, you know, thank y'all for being great students. Thank y'all for, you know, coming to class. Yeah, there's nothing much to say. I don't know.
It's been a pleasure, guys.
Yeah, it's been a pleasure. All right, so yeah, that's basically it. If y'all have any questions about, you know, anything in general, app dev, or want to bother me with A4, feel free to come up and ask me.
Quick question.
Yeah.
How would you go